Good evening all participants. Please raise your questions. Today is a live interaction session of what has been happening over last 2 months. If you have any doubts on any of the topics, please write it down. We will get it here, I will answer. We had some questions which had come to us beforehand. Let me just read out those questions and try to answer those questions. Not many questions have come, only very few questions, and please raise your questions, send it to us, and I can immediately see that and answer. And if we do not get enough questions, we will just try to elaborate on some of the questions that has been asked. So, let me just read out the first question. The first question is by Sonia Verma, and the question is that in a certain software, the system searches the book in the book list based on the keywords entered. After making the search, the system should output the details of all books whose title or author name match any of the keywords entered. The book details to be displayed include title, author, name, publisher, etc. How can we document the functional requirements in a SRS document? Okay. If you remember the lectures that we had, IEEE 830 is the standard template for documenting requirements, and in the section 3 of the IEEE 830 requirements are the specific requirements, where we write about the functional requirements. And the statement that I read, the question that has been asked, that the system searches a book from the book list based on the keywords entered, and after making the search it outputs the details, and the book details that are output include certain fields. So, this is just one function, and we start this by writing the name of the function. In section 3.1, we write a function name, maybe F001 or something, and then we write the name of the function, and from here it is clear that the function is about search book. And let me just write that out. Okay. Name of the function, we give a function name, let us say F001, and name of the function is search book. And below this we write a small description of the search function. It accepts a keyword and matches it with the book title, matches it with the book title, and outputs the result. So, this is the overall description of the search book, and then we write the input, which is a keyword, and if we know the details of the keyword, like it is a text string or it is a number or something, or it is a book title, we write that, or it is author name, or it can be either author name or book title, we write that, and the output we write the details that has been written here, that is the author name, publisher name, year of publication, ISBN, catalog number, etc. But then it is a good practice to identify alternate scenarios. This is okay. Let me just mention here is that the IEEE 830 just says that what are the sections and the template, but does not really tell how exactly to document one function. So, if we do like this, that is okay, but we can also identify alternate scenarios. For example, if the book does not exist, book is the title does not match, or it is an invalid title, and so on, what are the output that happens, the exceptional conditions and so on. But then this much is acceptable. Now, the second question is about a Halsteads metric. How, given a function factorial, how can you calculate the Halsteads basic measure? Okay, we did not really discuss this in our lecture, and I do not think that it is fair to answer this question, because this is slightly requires knowledge. Those who have not studied it will not make sense, because you have to compute the operators and operands, and we should define what are the operators, what are the operands. So, I will skip this question, but then Sonia Verma, who has raised this question, can just send me a email and I will answer that question on mail. Now, the third question is that what is CMM, and describe what are the levels and compare it with ISO 9001. Again, this is not part of the lectures, but since this was a topic we had planned earlier to include, but due to lack of time we could not include. Today in this 1 hour, if we have time left over, we will just go through this, that what is the CMM model and how does it compare with the ISO 9001 model. The next question is that a company is experienced in developing payroll software for different organizations. So, that means it has developed payroll for many organizations. A new order has come for developing payroll for one educational institution. Which life cycle model it should use? Okay. Please note here that it has experienced people and it has developed many similar software. Now, it is going to do one more of that with small variations. And since if it is a code reuse case, that okay, it is to tailor one of the payroll software that has been developed and just make small changes for an educational institution, then an agile model like Scrum or extreme programming can be used effectively if it is mostly small changes to the existing software. But if it is based on the experience develop entirely new software without reusing, then a waterfall model will be suitable, because they have a lot of experience, they know what exactly to do, and for developing from scratch waterfall model is a good model and waterfall model can be used. So, for this question we need to know further detail whether it is a small modification of the existing software or it will be developed entirely new. Now, let us look at the next question. The question is about deriving test cases, and here it says that if you take a train before 9:30 a.m. or in the afternoon after 4 a.m. until 7:30 p.m., you pay full fare. A saver ticket is available on the train between 9:30 a.m. and 4 p.m. and after 7:30 p.m. What are the partitions and boundary value, and which are the valid partition and which are invalid partition, and what are the derived test cases for this. Okay. So, here if you take the train before 9:30 a.m., 9:30 a.m. So, that is before 9:30 or in the afternoon from 5 p.m. 4 p.m. until 7:30 p.m. you pay full fare. So, this is full fare, and here it does not specify before 9:30 a.m. means is it from 12 a.m. 12 a.m. that is midnight to 9:30 a.m. it is not specified, and that from 4 p.m. to 7:30 p.m. you pay full fare. A saver ticket is available on train from 9:30 a.m. and 4 p.m. So, this is the saver ticket. So, this is full fare, and 9:30 a.m. to 4 p.m. is a saver ticket, and also after 7:30 p.m. is the saver ticket. Now, the equivalence classes are here: the first equivalence class, second equivalence class, third equivalence class, fourth equivalence class. We need to take one value from each of these for the equivalence class. Now, let us look at the boundary. The boundary, what about exactly 12 a.m.? What about just after 12 a.m.? What about just before 12 a.m.? Similarly, what about exactly at 9:30 a.m.? What about just before 9:30 a.m. and just after 9:30 a.m.? Similarly, for other boundaries. So, these boundaries we need to consider the boundary value just above and below the boundary. So, those are the boundary value test cases. Now, let us look at the next question. This is if you hold an over 60 rail card, you get 34% discount when you buy a ticket. If you are traveling with a child under 16, you can get a 50% discount on a ticket if you hold a family card, otherwise you get a 10% discount. You can hold only one type of rail card. Create a decision table showing all combinations of the fare types and the resulting discounts. So, if we read through the statement, one is that if you hold a 60 rail card, above 60 rail card. The second one is a family card. The third condition is about child traveling with child. Okay. So, now for each of these combinations we need to check. If it is above 60 card, then these two do not matter, and it says that you can hold only one type of card, that is a constraint here. And you get a 34% discount. So, this is the condition, and this is the discount. This the discount is 34%, and if it is not a above 60 card and it is a family card and you do not travel with a child, you get a 10% discount. If you are not above 60 and you have a family card and you are traveling with a child, you get a 50% discount. And if you okay, these are and it says that you cannot hold two types of card at the same time. Okay. And if you are traveling with a child above 60, okay, already taken that into account here. So, only these 3 test cases. So, if you are above 60 card and you are not, it does not matter about traveling with a child, you get 34% discount. If you are not above 60 and you hold a family card and not traveling with a child, you get 10% discount. And if you are not above 60 card and you hold a family card and with a traveling with a child, you get 50% discount. I think that covers all the scenarios. So, there are 3 test cases and each one become a test case, because you must hold one type of card, that is what is understood from the problem, and you cannot hold 2 cards simultaneously. You cannot hold a family card and above 60 card at the same time. Now, the next question is that why is path testing impractical? Does path testing subsume statement coverage? Path testing is impractical. The main reason is due to infeasible paths. In an infeasible path, the conditions are such that, let us say here we have a condition x greater than 100, if x greater than 100, and then we have if x let us say less than 50. So, we cannot have both these as true. If we have this as already greater than 100, then we cannot have this as true. So, when this is true, this cannot be true. So, all possible path combinations will not be possible, all possible condition on the different conditionals, all possible paths. For example, this is true and this is true cannot hold at the same time, and therefore, these we call as infeasible paths. And this is a clear case where we can identify infeasible path by looking at the expression. But many times the expressions are such that the values of the variables are not this much straightforward, and this can be, let us say y, x greater than y, and this can be a, and so on. And therefore, from a code analysis we cannot identify all infeasible paths, and it is not possible to design a test case which will cover a test case cover a path where x is greater than 100 and x is less than 50. So, achieving 100% path coverage is difficult, because every practical program will have infeasible paths, and on the average 20% of the paths, 10 to 20% of the paths are infeasible. And therefore, if you get 90% path coverage, you can think that the other 10% possibly are infeasible paths and you cannot cover that. The question that you might ask is that, is it possible to identify how many infeasible paths are there, so that we can, if there are 10% infeasible paths, if we get 90% path coverage, then we can assume that full path coverage has been achieved. But unfortunately, from a code analysis, we cannot determine all the infeasible paths. Few infeasible paths, straightforward paths we can determine, but all infeasible paths we cannot determine based on code analysis. And that is the reason why for a practical program we cannot achieve 100% path coverage. So, this is a good question, that why we cannot achieve 100% path coverage. So, this the answer is due to presence of infeasible paths. Now, let me look at the next question. A software developer may unconsciously not test his software thoroughly. Why would a testing coverage criterion help? This is a rather straightforward question, that you keep on testing, but how do you know that you have tested it well? And that we said that for white box or even for black box, a coverage metric need to be defined, and the coverage metric says that what are the possible test elements that we have covered. For example, for let us say statement testing, we measure how many statements, what fraction of the statements have got executed, and therefore, the coverage metrics are very important, because they let us know how thoroughly we have tested the code. Without using a metric, coverage metric, we will not know that whether we have tested it well. Now, let me just look at the other question. I am keen to do some research work in software testing, and what are the some of the initial articles, papers, tools, etc., that we should read. So, you just look at the Google Scholar and the Google type Scholar, the Google search, type Scholar. The Scholar is for identifying all papers and articles in an area, and once the Scholar comes up, there enter software testing and look at only the recent papers, and most of the papers you must be able to download. And if you need specific help or any specific paper, you just send me a mail, we will try to help in that manner, and look at papers which are published in last 5 years, and then see a paper which is interests you, and that is the point to start the research work. Now, let me read one more question, which is from Monique Kakote. Says that sir, how to get certificate, theory is getting boring. See, the thing is that theory you cannot do without it, theory has to be there, and you have to get a certificate, you have to go through the theory. There is no shortcut, please go through the theory, and you have to appear, complete the assignments, appear in the test, and that is how we got the certificate. And are there any further questions which have come? Okay. There is one question which is, what is feasibility study? Okay, this we had discussed in the lectures. The feasibility study, once the customer or there is a proposal to develop a software, feasibility study is undertaken. The feasibility study is undertaken to determine that whether it is worthwhile to develop the software, and that is whether it is cost effective, whether we have technical capability to develop the software, and whether we can operate the software. So, we had said about 3 types of feasibility. The cost feasibility. So, we in the feasibility study, if you remember in the lectures, we had taken some case study and had said that we need to understand what exactly is required, overall understanding, and based on the overall understanding we decide a high level solution to the problem and then estimate the cost, how much it will cost to develop, and then look at whether the time duration that the customer requires, whether we can develop within that time, and also whether we have the requisite technical expertise to develop the software. So, the cost feasibility, the technical feasibility and the operation feasibility, that after developing whether it can be deployed satisfactorily. So, these are the 3 main feasibilities that are addressed during the feasibility study, and once we complete the feasibility study, based on the study report we decide whether to go ahead with the project. Then we undertake the requirements specification, and if we decide that no, it is not feasible, maybe due to cost consideration, maybe because the duration is too short, or maybe because we do not have the technical expertise and so on, then we just abandon the project. So, the second question is very basic question, that what is software engineering? This we had discussed in the first class, that software engineering we can consider it to be the collection of experience of all the past programmers, nicely arranged in terms of methodologies. And if we understand all these methodologies, it will help us develop a program in the most efficient way and a good quality program, and that is the IEEE definition. So, request those who asked the question what is software engineering to revisit the first lecture, please go through it. We have discussed exactly this question. Are there any other questions? Okay. The second question, okay, here the question that has come is cohesion and coupling. We had discussed this in possibly in the 4th week, that when we design a software, we measure the goodness of the design, that how well we have designed in terms of some metrics or characteristics of the software. Cohesion and coupling are characteristics of a module, because the high level design, when we design, we first produce the high level design. The high level design is the module structure, and in an object oriented design, this is the class structure, and how well is the module structure defined? To measure that, we look mainly at 2 characteristics, that is cohesion and coupling. We see that whether a module does a set of related work and are two different modules are too much interrelated, they invoke each other's function frequently, then we say that they are coupling. There is a tight coupling between them if two modules invoke each other very frequently and pass data among each other, and then we say that they have a tight coupling. And cohesion is a measure of the functional strength of a module, that is whether it does a set of related functions, and based on the cohesion and coupling we decide whether it is a good design, and a good design should have modules should have high cohesion and there should be low coupling. We cannot have zero coupling, but then the coupling should be low. And this we had discussed with examples and so on, what are the different types of cohesion, what are the different types of coupling, how do we know that a function has high cohesion, a module has high cohesion, and then we defined what are the different classes of cohesion, and based on that we said that something has high cohesion or low cohesion. Similarly, what are the types of coupling that can arise, and what is a high coupling, what can be considered as a high coupling and what can be considered as a low coupling. To discuss the entire thing, it will take lot of time. We discussed cohesion and coupling over one full lecture, if I remember. So, we cannot really discuss it now, and please look through the lecture. And now, the second question is, what is concolic testing? Concolic testing actually we did not discuss, because it is still a research subject. See, in testing, one of the important problem is test case generation. Test case generation and in test case generation we have to decide what are the test data that is to be input, and so far the test tools that we have, they do not really generate test data. We can only replay manually designed test cases. We have to design the test data manually and we can only replay that. But the concolic testing is a technique which promises to generate test data automatically based on a random execution and then symbolic evaluation of symbolic conditions, symbolic expressions involving symbolic variables. It is an advanced topic and we not really discussed this in the our lectures, but then as a general idea, concolic testing is about test case generation. It helps us to generate test values automatically, a promising approach, and beside that we will not discuss much detail. It is more of an advanced research topic. Now, the next question, let us look at it. What is level 0 DFD? Okay. So, if we remember the lecture about structured analysis, we perform structured analysis by using DFD, and here we represent the data flow to the software, and this is a hierarchical diagram. In the data flow diagram, we represent only the data flows, and at the very basic level or 0 level, level 0, which we call as the context diagram. Level 0 is the context diagram, and here we identify the software as a single bubble, and then we identify the context in which the data flow to it occurs, that is what are the external entities and what are the data it input to the software. So, the software is considered as a single bubble. We write the name of the software here, for example, a trade house automation software, and we write 0 here to indicate a level 0 DFD, and this we call as the context diagram, because here we represent the context in which the software exists, and these are the external entities or the users. The user may be a customer, it may be the clerk, it may be the manager. So, different types of users, they are the external entities, and this may be a sales person, and what type of data each of them input here, we represent that using an arrow, and what is the data they receive here, that we represent here. So, basically the level 0 DFD captures what are the different users and what data they input to the software and what data they get from the software. And then based on the level 0 diagram, we develop the higher level DFDs. Okay. So, this is about what is level 0 DFD, which is a context diagram. It represent the context in which the software exists, that is the specific users who are going to use the software, it exists in their context, and what type of data they input to the software and what type of data they receive from the software. Now, let us look at the next question, which is about the cyclomatic complexity. Actually, if you remember the lectures, we had discussed that given a program code, it is very difficult to determine the number of paths in the code, because if the code has let us say 100 statements and let us say there are many loop and conditional statements, we can develop the control flow diagram, but manually tracing through all the paths, the basis path set is very difficult. It can take months or years for a moderately complicated function to identify all paths in the function, and the cyclomatic complexity gives us a bound on the number of paths that can exist. Cyclomatic complexity measure gives us a bound on the number of paths in a code segment, in a code, and it is easy to compute. We had discussed 3 ways to compute. The first is we represent the control flow diagram from a program code, and then we count the number of edges minus number of nodes that are there in the control flow diagram plus 2. So, this is the cyclomatic complexity measure of the code, and then the second way we had said is that the number of bounded areas in the control flow diagram plus 1, and the third way we said is that the number of decision statements plus 1, and all of them they give the same number, and it is easy to compute, because you can look through a code and find out how many decision statements are there. Each of the if, then else, each of the loop and so on, they are decision statements. You can count them and add 1 to that, and that gives us the number of paths, and then we know that how many test cases are needed, at least how many test cases are needed to achieve path coverage on this, and that indicates what is the testing difficulty or what is the testability of the code, and it also indicates that how easy it is to understand the code. If there are too many paths, it becomes difficult to understand the code. So, the cyclomatic complexity is an important metric, and it helps us to identify at least how many test cases are needed for path coverage, what is the testability of the program, how easy it is to understand the code, and so on. So, it is a very important metric, and please look at the lecture again, we discussed it quite elaborately. Now, the next question is difference between validation and verification. Okay. In verification, because the software is developed over a number of phases, and in each phase we produce a work product and look at the next, and the next phase starts based on the work completed in the first phase. For example, this may be the requirements, and based on the requirements we start the design activity, and based on the design we do the coding and so on. And it is necessary to verify whether the design that is completed here at this phase, whether it is as per the requirements, and similarly whether the coding is as per the design, and so on. So, this is a verification step, and the main goal of verification is to identify the bugs as quickly as possible, because if we do not verify this, that whether the design is as per the requirements and the code is as per the design, we will finally find them possibly at the testing, and it will become very expensive, because the problem may be here that the design is not as per requirements. So, in verification we try to verify whether the output of one phase corresponds to the output of the previous phase, and it helps us to reduce the cost of error correction. On the other hand, in validation we take the completely built software and test that against the requirements. So, whether the fully built software is error free, that is the focus of the validation, and we do validate during the system testing. The focus of system testing is validation, because the system test cases are designed based on the requirement specification document, and we validate based on that. Okay, I hope that answers the question between verification and validation. In any case, we discussed it during our lecture quite elaborately. Are there any further questions? Okay. Please explain sandwich testing, Big Bang testing, stress testing, and mutation testing. Okay. Sandwich testing we did not discuss, and also I am not aware, so will not discuss about that. Big Bang testing is about a integration test strategy. Big Bang testing it is a integration test strategy, and here the integration testing is performed by integrating all modules together typically we use it for very small software, only few modules, 2, 3, 4 modules, and for large software having dozens of module, do not do big bang testing. Can you identify the reason why big bang testing is not done on a large software? Please think about it, and just to give a hint, it is the reason why we do not do big bang testing is about the cost of fixing bugs, because if we integrate 2 modules or 3 modules and we find that there is a bug, there is a failure, then we know that the bug will be there in any of these 2 modules. But if we integrate a dozen module and then there is a failure, we do not know which module has the bug, and therefore, we do not use big bang testing for testing large software. It is only used for very small software. For large software, you use incremental testing. Now, the next question is incremental model and spiral model. Okay. In the incremental model, as the name says, that we develop in increments. So, at a time we develop some features and deploy it at the customer site, and then implement additional features and so on. Whereas, the spiral model, we said in the lectures, if we look through the lecture, I think we spent some time on the spiral model. We said that the main focus of the spiral model is to handle risks efficiently, and this is the main characteristics of the spiral model, that if a software has large number of risks, then we deploy a spiral model, and we had discussed about the case study of Iridium software. We said that large software and it was not deployed anywhere, first time we are developing very large software, and therefore, there is bound to be many risks. And here in spiral model, we take up a feature which is most risky, handle the most risky part, and then develop a prototype to contain that risk, and then develop the one increment, and then develop the next increment, and so on. And the spiral model actually incorporates incremental model. Now, next question is, what are the topics most important for the exam purpose? Okay. For the exam purpose, the questions are spread across all subjects, and these are mainly objective questions which will be asked. And as you know, in the MOOC testing, that the questions range from very simple questions to more complex questions, and the questions are spread over the entire syllabus. Any other questions that have come? Okay. The next question is about regression testing. When we change a software and we change it for many reasons, for example, during testing we might find a bug and then we need to change the software, need to correct the bug. Let us say this was the software and we found that some part was problem, this was causing the failure, and we fixed the bug, and maybe the feature that was failing, the test case that was failing, maybe it passed. But is it possible that the test cases which are already passing these were already past test cases. Is it possible that they can fail? That is the question we are trying to address during regression testing. But then you might ask, is that see, if a test case was passing earlier by fixing a failed test case, why should a past test case again fail? Okay, the answer is that it might change some global variable or something such that the past test cases are getting affected, and the ones that were passing earlier, they may fail. And therefore, it is once we change the software for whatever reason, maybe because of a bug fix, maybe because we wanted to add some additional features, maybe we just want to make it more efficient and so on. But finally, we need to check whether the test cases which are already passing, whether they will pass again, and that is the focus of regression testing. But then you might ask the question that is regression testing done after unit testing, integration testing or system testing, that we find a unit testing bug and then do we do regression testing. If we find a integration testing bug, do we do a regression testing, and a system testing bug, do we do regression testing? Okay, the answer is that yes, for all the types of testing, when you find a bug, you not only fix that bug and see that the test case which was failing is passed after you fix the bug, but also test whether the test cases which were earlier passing, whether they still continue to pass. And because we are running the test case again after a fix, we call it as regression testing. Okay. Now, let us look at the next question, which is how do we do black box testing for a particular software. Okay. The black box testing, as the name says, we design the test cases without looking at the code, that is based on the specification. So, based on the input output data, we design the test case, and there are many strategies that we had discussed. If we remember, we had discussed about equivalence partitioning and boundary value. This equivalence partitioning, boundary value testing, and in equivalence partitioning we said that look at the data, input data, output data, find the classes of data for which the software behaves similarly. So, if this is the total amount of data that is to be input, we look at the behavior, that is in terms of the output, and we define equivalence classes. The main idea here is that since the behavior is same for all data in a class, it is good enough to take just one data element and test the software, because if it passes for any one of the data element, because it produces similar behavior, it should also all other data element in the same equivalence class, they should also pass. So, we define the equivalence classes and we select one element from each of the equivalence partition. We had taken several examples, if you look at the lectures, how to define the equivalence classes and what happens when there are multiple parameters which define different class hierarchies. And on the boundary value testing, we said that the boundaries of the equivalence classes are some special values, and these special values can contain bugs, because the programmers often write program where they overlook the boundaries. For example, they might write greater than b, whereas they should have written a greater than equal to b, and so on. So, the boundaries are risky values, the boundary values are risky values, and we must test whether the software is working correctly at the boundary value. And we had also discussed few other black box testing techniques. We had discussed about the combinatorial testing, pairwise testing, decision table testing, and so on. So, please look through the other black box testing techniques, because we are running out of time now. Are there any other questions? One last question, because running out of time. Is there a question? Okay. So, we will just take one last question. Because we are already at the end of the hour. So, the question is about one question, possibly it is from a teacher who has asked that whether DBMS course should be taught earlier or the software engineering course should be taught earlier. Okay. The software engineering course, the requirement for this course is only some programming background, do not need any other background. So, the software engineering typically taught in the second year in the BTech curriculum, whereas the DBMS that requires data structures, algorithms, discrete math, and so on. So, maybe the DBMS course is taught later in software engineering, but there is really no dependence of software engineering on DBMS and vice versa. But then the software engineering has only programming as background, and therefore, it is typically taught early in the curriculum, whereas DBMS has many courses as its prerequisite, and therefore, it is typically taught later in the BTech curriculum. Okay. Since we are running out of time, I just want to thank you for raising a large number of questions. I was thinking that there may not be enough questions, and thought that we will discuss some topics here, but that was not necessary. So, again thank you for all the interactions and all the questions. Best of luck.